In this example, we're going to learn how to sketch a graph for a polynomial function that's written in the factored form. We will do that by determining end behavior, zeros, multiplicities, y-intercept, and then sketching the actual possible graph. This is not an exact graph, this is a sketch, so some values are not going to be exactly what this function is doing, but we're going to be pretty close on the shape. So let's start with the degree and the leading coefficient. The degree for this function, there's two parentheses that are x plus 1, and then there's one that's x minus 2. So there's three x's present altogether. So this is degree 3. Leading coefficients, there's no number in front of the first parenthesis, so it's just 1. So we have an odd degree and a positive leading coefficient. So my ends should look like this. Okay, keep that in mind. We'll come back to that. Now let's go ahead and talk about the y-intercept. That's pretty easy to find. So we'll start there. So the y-intercept is where x is 0. So we just need to plug in 0 for x and figure out what y is. Y equals 0 plus 1 squared, 0 minus 2. Well, 0 plus 1 is just 1. 1 squared is still 1 times negative 2. So my y-intercept is at negative 2. I'll go ahead and plot it. Now let's look at the zeros for this function. X plus 1 squared x minus 2 equals 0. So we'll go ahead and use the zero factor property to solve for x. X plus 1 equals 0, x equals negative 1. Now this parenthesis was squared, which means there's two of them, which means that multiplicity on negative 1 is 2. The even multiplicity means that at x equals negative 1, the graph is going to touch the x-axis, but it's not going to cross. It's going to touch and then turn and go in the other direction. Sometimes we describe it as bounce. So if imagine a rubber ball bouncing off the floor, that's usually what happens here. So then the second parenthesis, x minus 2 equals 0, x equals positive 2. On this one, multiplicity is 1. Odd multiplicity means that at that point, the graph is going to cross the x-axis. So let's go ahead and plot these on the x-axis. So x equals negative 1, that's right here. X equals 2, that's right here. Now this is where we actually consider the ends. So I know that my left end should point down, so I'm going to go ahead and draw it in. And then I know that my right end should point up, so I'll go ahead and draw that in. Now, starting on the left-hand side, you are going to start connecting the dots. So from the end, we're going to go to the first 0 at negative 1. That 0 has an even multiplicity, so it's not going to cross the x-axis. It's going to touch and then turn and go back down. It's going to go ahead and go and connect through the y-intercept. So here's this particular point is where it's a sketch and not a graph. We don't know how far down it goes from here. So we can go really down, or we can just go ahead and turn almost immediately. I'm doing an immediate turn. I actually don't know how far down it's gonna go. We're gonna connect it to the next 0. At 2, the graph should cross the x-axis, which is great for us because we need to connect it to the other end, which is what we're gonna do. So that's it. This is a sketch for this polynomial function. Let's look at a different one. Okay, so this function will start with a degree and the leading coefficient. Degree will be 1x, 2x is here because the parenthesis is squared, so 1 plus 2 is 3, and plus another 1 degree is 4. Leading coefficient is negative 1. So for this function, even degree, negative leading coefficient, both ends will point down. Now we'll do the y-intercept. and that is when x is 0. So plug in zeros for x is negative, 0 plus 1, 0 minus 1, square this one, and 0 plus 2. So what this is, it's negative 1 times negative 1 squared times 2. And if you calculate it all together, that is going to be at negative 2 again. So right here. Now zeros of this function. So negative x plus 1, x minus 1 squared, x plus 2 equals 0. The negative on the front will not affect our results. This is x plus 1 equals 0, x equals negative 1. Multiplicity on the first parenthesis is 1, so the graph should cross at x equals negative 1. Now x minus 1 equals 0, which means x equals 1. So multiplicity on this parenthesis is 2 because it was squared to begin with. So at that point, the graph will bounce or touch and turn. And then x plus 2 equals 0, x equals negative 2. Multiplicity, 1. Odd multiplicity, the graph should cross at that point. So let's go ahead and actually put the zeros on the x-axis. Negative 1, negative 2, and 1. And then the ends, I have not put the ends down yet. So the ends, left end points down and right end also points down. Let's see if we can connect the dots. So I will start at the left and go to the first 0 at negative 2. The graph should cross the end to the first 0 at negative 2. The graph should cross the x-axis. So we'll go ahead and cross. Now we don't know how high it goes from negative 2 to negative 1. That's why it's a sketch and not a graph. So I'll go ahead and connect it right away. At negative 1, the graph should also cross the x-axis. So we'll go ahead and cross into the y-intercept, and then y-intercept you always cross and then go to the next 0. At 1, multiplicity is 2, so we're not crossing the x-axis at 1, we're actually just touching, turning, and connecting it to the other end. And this is a fairly accurate sketch of this polynomial function.